So I'd like to talk about some measures of central tendency and show you how to calculate them. So a measure of central tendency is if you had to pick just one number to describe an entire set, what number would you pick? Okay. So there are three that we typically choose from, and those are mean, median, and mode. So mean is sort of like the official name for what we mean when we say average. Right, so average, this is where you add them all up. So add up all the values. And then we divide by how many? By the number of values. Okay. Median, this is the number in the middle. So it's like the middle number of your set when the data is organized, so smallest to largest or right the other way. And then mode, this is just most often. Okay, so here I have a set of numbers. 1, 2, 3, 1, 2, 3, 4, 5. So I have 15 numbers, and we need to determine, let's go ahead and do all three measures of central tendency. So to do the mean, what we're going to do is we're going to add up all of those numbers and then divide by how many? So 75 plus 79, I'm not going to write them all out, so plus dot 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 plus 81 plus 90, right? And then we divide by how many, and I just counted and there were 15. Okay, so I'll go ahead and grab my calculator. And hopefully I don't lose a number here. So 75 plus 79 plus 80 plus 81, right? We just type them in and then we can check, right? So as we're kind of keeping track of these types of numbers as they're going in. Oh no, I just hit an enter. 81. 97, 67, 88, 91, 79. So I got to the 79 before I hit enter. Okay, there it is. Can't talk and chew gum. Plus 88, plus 81, 95, 81, 90. Okay, so the numerator that I got is 1255. And then divide by 15. So what I was saying is that we kind of get a feel, right? If I have a number that's not somewhere between 67 and 91, it's going to be like, well, I don't think that's quite right. So let's see, divide 15, 83.67. That seems about right to me. Except I didn't write it correctly. 83.67. It seems reasonable. Now, I might have typed in one of those numbers wrong, but hopefully not. So mean, add them all up, divide by how many? Median, we need to organize the data. Now, I'm a little overwhelmed by that much, so I'm going to do a quick little stem and leaf plot. So I have 9s, 8s, 7s, and 6 just to see my data. So these are the tens places. And then I'm going to put the 1s over here for the leaves. This is called a stem and leaf plot. Just a little extra. You don't have to be able to do it, but I do to organize. So 75, I just put the 5 over here and then I see what I've got. 79, 80, so that 0 is going to go up here by the 8. 81, 97, 67, 88, 91, 79, 88, 81, 83, 95, 81, 90. Okay, so then if I want to organize them, it is, I'll put them down here. So 67's the smallest, then 75, 79, 79, and then I've got an 80, and then I've got 3 81s, and then an 83, and then 2 88s. See, 1, 2, 3, 4, 5, 6, 7, and the 8s, 1, 2, 3, 4, 5, 6, 7. That's good. And then my 90. So then I've got 90, 91, 95, 90, 91, 95, 97. Okay, there we go. So then who's in the middle? So I can either slash into the middle, or right, you can do some math with that. If there are 15, you divide it by 2 to get 7.5, round up to 8. It's the number in the 8th position. So 1, 2, 3, 4, 5, 6, 7, 8. I think it's going to be 81, but let's see. So if we slash in, so boom, 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 boom. Here, yep, 81. Nice. 81 is in the middle once you've organized it. Okay, mode, most often. Which one of those numbers happens more than any other number? Let's see, I've got 279s, I've got 288s, but I've got 3 of the 81s. That's the only one I have 3 of. That makes it the mode. Okay. Now, weighted mean. So now if you have an instructor who weights for grades, and let's say the weighting is 50% exams, 20% homework, 10% participation, and then 20% on the final exam. Weighted mean means, right, each of your percents in those categories gets weighted, right, with these values. So let's say you have 74% on your exams, 80% on your homework, 60% on your participation. Oh, I know that wouldn't be you because you do like much better participation. 70% on your final. What is the total percent in the class? Okay, so the way we do it is we're going to multiply. So we're going to take 50%, right, of, right, your 74 on your exams. So I'm going to do 50% times the 74. I'm not going to do the percent there. I'm going to get too many percents involved. So we'll just, let's do it the other way. So I'm going to do 50 times 0.74. I'm changing that 74 into a decimal. And then we have 20 times, how much did you get in your work? 80%. So change the 80% into a decimal. And then 10% participation. And you had a 0.60 for your participation. And then finally, you had 20% on your final exam, and that was 70. So that's a little confusing when they're both percents, but that's okay. So the reason why I chose to make the percents on the actual scores that you got instead of on the weights is just because I know that my weights all added up to be the 100, right? And those guys were not that. Okay, anyway, so then to find out your total percent, we're going to multiply. So we're going to do 50 times 0.74. And then 20 times 0.80. And then 10 plus 0.6. And then we add these all up. And then plus 20 times 0.7. So that your average, and you should have some kind of idea like going in, what does that look like to you? What would be a reasonable value? I'm just typing in those numbers. Looks like a 73. And then in case you were curious, like, well, what if I did the percents on the other one? It does turn out to be the same thing. So if you would have done 0.5 times 74, 0.2 times 80, 0.1 times 60, 0.2 times 70, same exact number, 73. Right? Nice solid C. So to compute your GPA, your grade point average, the way you do it is you take the numeric value for the grade, the letter grade, and you multiply that by the number of credits, but then you divide by the total number of credits that you had. Okay. So the reason why when we did weighted mean for your grade in one class that we didn't do it is, right, we divided by 100, right? That was, right, divided by the 100%, divided by 1. Because all of the weights add up to be 1. Here, the credits are the weights. So it's like you have 5 versions of A. So you could have 5 4s, and then you have 2 at the 3.0s, right? And then 5 at the 3.3s. So you could just sit and add all of those up, but there's an easier way. So we take the 5 times the weight times the value for each of them. So 2 is the weight times the value. 5 times the 3.3 for your B plus, and then 5 times the 2.7 for your B minus. But then where you need to divide that by the total number of credits that you had. So 5, 10, 15, 17. And that will give you the quarter GPA. Okay. So doing the numerator first, so 5 times 4 plus 2 times 3 plus 5 times 3.3 plus 5 times 2.7. So it looks like 56 on the top divided by 17. That looks like a GPA of 3.29. Does that seem reasonable? I guess so. Yeah, I suppose, right? That B, right, that's a little bit lower. The B minus is a little bit lower, kind of offsets. It's really close to that B plus that you got there. So the A helped bring some of those other ones up. Sure, that seems like a reasonable value.